This is a completely free open source pipeline that will allow you to train Gaussian splats from video inputs in 3 steps. As an example, we'll be transforming this video and converting it into a Gaussian splat. Now you might have seen other examples of research, but you won't need to know all of these mathematics, you won't need a degree in computer science. These individual points, instead of pixels, are made up of 3-dimensional voxels, roughly in the shape of an oval. This pipeline consists of 3 distinct steps. The first step is frame extraction, which extracts individual frames from your video. Second is structure from motion, which detects features on individual frames of the video and looks for how your camera moved through the scene. For these first 2 steps, we'll be using Reality Scan from Unreal Engine. The third step is Gaussian training. Gaussian training takes the structure for motion files from Reality Scan and trains the individual 3D point cloud into a 3D reconstruction, almost like a model that you can navigate around from any angle. This third step will be done using a free open source software called Brush, which is available on GitHub. All of these links to these downloads will be linked in the description. So let's get started. First step is to download Reality Scan. So you can download this from the Epic Game Store if you already have it. Secondly, we'll be using this brush made by Arthur. All you'll need to do is hover over this green code button and click the zip download. So open up Reality Scan, and inside Reality Scan you can either import a file or open the Finder and just drag and drop the video file into the workspace. And by doing this, a window pop-up will show you the name of the video sequence you've just dragged and the frame intervals. So the frame intervals are under a name called jump lengths. Jump lengths just tell you how many frames you want to get per second. So if you've got 30 frames and you want every frame, you can put 1/30th of a second. The default setting is exactly 1 frame per second, but I'd like to take 2 frames per second. So I'll be adding 0.5. So the importing doesn't actually take that much time. So what it's doing now is extracting all the frames from the video. So now we'll hover over the top bar and click on the Align tab and select Align Images. So this is the structure for motion phase. What it's doing is detecting features around all the frames together and trying to create a cohesive pattern which generates a point cloud. So this should take a few minutes. Once that's done, you'll see this beautiful point cloud, including the camera path that's been detected from feature matching. So as you can see, this is the flight path that the drone took during the live stream, and you can navigate and double click towards the center of the model to select your axis of rotation, just in case your rotation axis is slightly off the center. Now, once we're happy with our point cloud, go to the top left corner and click the Reality Scan icon and select Export. And we'll select COMAP text format. You'll be able to find that if you scroll somewhere towards the bottom. So COMAP is the structure for motion model that allows Brush to understand the point cloud information and generate 3D Gaussians from that. So make sure to name your file consistently without any spaces. And when you have the export pop-up, make sure to go over Export Images and select Yes. This will generate a second set of images of all your frames in the folder that you've selected. Brush will use these frames to project the color information, the RGB information, onto the 3D Gaussians. Without this, you might have some issues training Gaussians in Brush. You might see some sharp splats or just blobs all over the place. So yes, it's an important step. You will see a duplicate set of images generated. Now, as we can see, once that's exported, we'll have a secondary set of frames. So let's just check frame 122. Depending on the input source, you might see some differences in the frames, for example, some cropping. But in this case, they look almost identical. So now we're happy with our COMAP text export. You can open Brush by executing the application. And once Brush is opened, click on the top left tab, Directory. This will open your Finder and select the folder in which you have placed all the COMAP text files, including the secondary generated frames by Reality Scan. So on the settings pop-up, 30,000 steps is that might take a bit of a while, so you can dial that down to 3,000 steps. I perceive a diminishing return beyond 7,000 steps, so I like to set it to 3,000, as that takes the shortest time with the minimal loss of quality. And this looks pretty good so far, so you can tell it's starting to take shape. This is the longest step, so this will take a few minutes. You can open controls, disable live update, so make your computer less laggy. I've just sped this up. You can see on the bottom left, you'll see the number of iterations, the number of splats, and how much time it's taken. So once that's reached the number of steps that you've set, Now you can open controls again and click export. So you can name that, make sure it's a .ply file, which will be used to upload onto the viewer. We'll name that SpaceX launch. And now we'll be going on to Super Splat. So I'll link this website in the description. If you've never used Super Splat before, this is also an open source, completely free viewer that you can just create an account on, upload your 3D reconstructions, and also edit them. This is a great tool because you can edit them and refine them and share with anybody that you like for completely free. All you need to do is create an account. It also maintains the fidelity and the quality of your splat. So once you've created an account, you can go onto Editor, click File, Import, and import that corresponding PLY file. So you can see it's beautifully set in, and we can disable this point view, a fancy way to see where the Gauss in the individual points are. So if you see some blobs like this sky that is out of place, what you can do is go to the bottom tool tab. And what's really useful about Super Splat is that you can highlight and brush over these blobs and just delete them. So let's say we like to have a snow globe effect and delete all the unnecessary blobs around the sky and the landscape. What we can do is click sphere and increase the radius of the sphere. Once we create our selection, we can go on select, invert to select everything outside of the sphere and just click delete on our keyboard. So that creates a clean spherical selection of our reconstruction, and it looks a lot better depending on if you want to keep the surroundings or not, but I think I'll keep them. If you'd like to see this exact reconstruction, I'll link the Super Splat viewer link in the description as well. So if we're happy with that, you can explore all the other tabs. They're quite self-explanatory and very intuitive, which is a credit due to the Super Splat team. If we'd like to export this, we can export this exact reconstruction as a PLY file with the edits made again. So another very interesting feature of the Super Splat viewer. So let's say we want to measure something in this scene. For example, distance. We can use a known measurement as a reference. If you go on this measurement tool down on the bottom toolbar, we can set a line on our rocket as a known length. So we know that the Starship height is 123 meters. So we can set that as 123. And it'll scale the whole reconstruction up. So let's say we want to know the distance between the main launch tower and this other tower here to the right. So we'll drag these points to the bottom, to the base of these towers. And as you can see, we'll have our new length, which is around 460 meters. So that's quite interesting if you're looking to conduct other measurements. We can just export this now and publish it. So there you have it. I wanted to make a clean-cut pipeline for people who are struggling with paid versions of PostShot or other 3D applications like Polycam, Scaniverse, or Kiri Engine. If you want to do this on your PC with videos that you've taken on holiday or heavy video files, you can use this 3D Gaussian pipeline for completely free.